Welcome to ScienceCover.com. First, pause the video and try the Do Now task. Let's look at the answers to the Do Now task. In this lesson, we will focus on the environmental effects caused by different energy types. We will focus on the greenhouse effect and how humans are contributing to the greenhouse effect, look at acid rain, and investigate issues with nuclear power stations. First, let us investigate the greenhouse effect. The greenhouse effect is an effect we see in the Earth's atmosphere, but is named after the glass houses used by gardeners. So how does the greenhouse effect work? The sun's light and heat shine down on the greenhouse and enter through the glass. This warms the inside of the greenhouse. The radiated heat tries to leave the greenhouse, but is reflected off the glass and trapped within. This results on the inside of the greenhouse becoming much warmer than the outside. A similar process happens in the Earth's atmosphere. The light and heat from the sun shines down, warming the Earth's surface. The radiated heat attempts to pass through the atmosphere back into space, but a layer of gases prevent this heat from passing through and reflect it back down to the Earth's surface. These gases are called greenhouse gases. Some of the common greenhouse gases are water vapor, methane, and carbon dioxide, or CO2. Now pause the video and attempt task 1. Let's look at the answer to task 1. Compare your diagram to the diagram on the screen and check that you have placed the labels in the correct locations. Let's look at how humans are contributing to climate change. We have seen how the greenhouse effect traps heat around the planet and is caused by greenhouse gases. But power stations, factories and cars burn fossil fuels, releasing CO2 into the air. This is a greenhouse gas and it may be increasing the greenhouse effect. Plants take CO2 out of the atmosphere, but deforestation has decreased the impact these have on CO2 levels, allowing the CO2 level to rise. Scientists have tried to prove a link between the CO2 level and the Earth's average temperature. By studying ice cores, we can look at how the carbon dioxide level in the atmosphere has changed over time. The red line on this graph shows the amount of carbon dioxide in the atmosphere at different points in the past. The black line underneath shows the Earth's temperature during the same period. We can see that there's a clear correlation or pattern between the two data sets. Now pause the video and complete task 2. Let's look at the answers to task 2. The greenhouse gases are methane, carbon dioxide and water vapor. Question 2, you have to identify the incorrect word in each sentence. So SO2 was the incorrect word, it should have been CO2. For part B, more was the incorrect word because deforestation leads to less trees and less CO2 being removed from the atmosphere. Part C was reduce was the incorrect word. Factories and cars burn fuels which increase the CO2 level in the atmosphere. For part D, there was 2 incorrect words. Fission fuels should have read fossil fuels, and it increases CO2 rather than decreases CO2. Why do scientists believe there's a link between CO2 records from the greenhouse ice cores and past temperature record sets? There's a correlation or pattern in the data sets. As the CO2 level rises, the temperature appears to rise. Let's look at the causes of acid rain. Coal contains impurities of nitrogen and sulfur. Whenever we burn anything, it joins to oxygen from the air. So burning the coal causes the nitrogen and sulfur to join with the oxygen and become nitrogen dioxide and sulfur dioxide. These gases rise high into the sky where they reach the clouds. Clouds are made out of water, so H2O. The nitrogen dioxide reacts with the water to create a new chemical called nitric acid. And the sulfur dioxide and the water react to form a new chemical called sulfuric acid. The acids can be carried a long distance by the winds, but eventually condense and fall as rain. If the acid rain falls on soil, then it makes the soil acidic, which can kill plants and trees. If it runs into rivers and lakes, then it turns the water acidic, which can kill fish and other marine life. This disrupts food chains and damages habitats. Now pause the video and complete task 3. Let's look at the answers to task 3. Coal or oil contains sulfur or nitrogen impurities. Burning the coal or oil joins sulfur and nitrogen to oxygen. This forms sulfur dioxide and nitrogen dioxide. SO2 and NO2 float into the atmosphere and mix with the cloud water. This creates H2SO4 and HNO3, which are acids. The acids fall from the clouds as rain. The labels should have read: number 1, factories burn coal, which contains sulfur. Number 2, SO2 rises into the air. Number 3, SO2 mixes with the rain, forming sulfuric acid. Number 4, clouds blown by the wind. Number 5, acid rain falls. Let's look at the issues surrounding nuclear waste. Nuclear power stations burn no fuels. This means that they produce no CO2, no SO2, and no NO2. This means that they do not cause climate change, and they do not cause acid rain. However, they do use radioactive fuel rods, which contain uranium, and after use these become highly radioactive plutonium, which will remain radioactive for thousands of years. Once used, the fuel rods need to be disposed of, so we call it waste, but as they are radioactive, we call it radioactive waste. Disposing of the used fuel rods is difficult, as they have to be encased in concrete and stored under water to prevent contamination. Nuclear power stations also have the potential to melt down. On the 26th of April 1986, Chernobyl power station went into a meltdown. This is a runaway process producing heat. At Chernobyl, this caused the reactor to explode, throwing radiation into the atmosphere. But the process can produce so much heat that the fuel rods become molten and burn through the ground until they reach the groundwater supply. Now pause the video and complete task 4. Let's check our answers to task 4. Nuclear power produces large amounts of radiation. Nuclear power stations produce no CO2 and has no effect on climate change. Nuclear power stations produce plutonium waste, which has a half-life of 24,000 years. Nuclear power stations produce no NO2 or SO2, so cause no acidic rainfall. A meltdown could heat the fuel rods until they melt and become molten, which could burn through the ground into the groundwater.